This video is to go over homework investigation 5A. So let's look at problem number 13. So it says use Sasha's regular approximation method to estimate the length of the car below. So the goal is to estimate the length of the car below. So here's what Sasha did, right? Sasha was instead of, so this is 2 inches, I guess. A little bit bigger than that, but anyways. So if you go, so there's no way that we can measure with this ruler. But what Sasha did was she took 1 point and she took another point. Okay, and then she measured that part. So that's 3/4. You know what? Let's do it easy way. Right. So let's take 1 inch here. So from here to here is 1 inch goes. And then she keeps going. Here's 1 inch here. Right? And then you can do, instead of doing 1 inch, you can do 1/2 inch here to make it, right? And then use another 1/2 here. Right? And if you go around, and if you add all the lengths, it's going to be the estimated length or approximated length of this curve. Okay, so that's what I want you to do. That's what this problem asks you to do. All right. Let's do problem number 5. So this problem has 2 parts, but both parts you want to find the area of each figure. One is a stop sign that has side of 6 inches long and upper thumb with 7.2. Okay, so the stop sign is octagon. So it goes like this, right? Each side is 6 inches. And the upper thumb is 7.2 inches. Okay? Theorem 5.1 says area can be found by 1/2 of perimeter times upper thumb. Okay? So in order to find the area of this figure, you need to find the perimeter of this figure. So each sides are 6 inches. I'm sorry, it doesn't look like it, but 6 inches, 6 inches, 6 inches, right? That's the perimeter, and the upper thumb is 7.2, right? So if you make it a 1/2, if you find the perimeter and make it a 1/2 and multiply by the upper thumb, you'll find the area of this figure, part A. How about part B? Part B says in the figure an equilateral triangle is inscribed in a circle. That means the triangle is the vertex of this equilateral triangle is just touching the edge of the circle, right? It says that circle has the radius of 2 centimeters. The center of the circle that circumscribes a triangle is the triangle's circumcenter. That means that's the point that it's a circumcenter. That's the medians, the concurrent points of medians, the points that all the median matches. So it says the circumcenter of equilateral triangle divides into the triangle's median into 2 segments, right? So this point is dividing this segment into 2 pieces, the longer one and the shorter one. That's what it says right there. One is twice as long, so this is twice as long as this one. The longer one is twice as long as the shorter one. This should give you enough information to find the side lengths of the equilateral triangle using the shaded triangle into the triangle using the shaded triangles in the figure. Shaded one is this one. It doesn't look very well, right? So we know that the circle of the radius is 2. So this is 2 right here. And we know that this guy is twice as long as the shorter one right there. So that should be 1. Right? What are we trying to find? We try to find the area of we try to find the area of what? Oh, let me see. We try to find the area of the circle for what, right? So that's what we need to find out. That's why it's important to find what the goal of this problem is. We need to find the area of each figure's, oh, the area of this circle. Okay. It's the area of this circle. This should give you enough information to find the side lengths of the equilateral triangle. Okay. You know what? Let's find the area of this triangle, right? So the area of the triangle here, well, area of the triangle is what? Half of base times height, right? So this can be a base, and we know what the height is. Height is definitely 3. But for this one, we have to find the base of it, right? So let's pay attention to this triangle right here. This is the right triangle. And the shorter side right here is 1. Longer side right here is 2. By using Pythagorean theorem, you can find the lengths of this one from here to here, which is from here to here, right? Once you find that, make it double because you have double of them. That's going to be the base of this triangle. Once you find the base, multiply by the height, which is 3, and make it a half. That's going to give you the answer right there. And that's it.